In this video, we'll continue working on the renderer horizontal class. More specifically, we're going to address some note rendering in our actual horizontal renderer. Now, if you remember, up to this point, we have some temporary drawing code taking place here in Draw, but we're actually going to be wiping that out. As a matter of fact, while we're looking at it, let's do just that.
I mean, you're not even going to copy-paste it? You're just going to delete it?
No, even though some of the techniques will be similar, maybe even some of the actual looping and note gathering may be the same, but rather than trying to weave in and out of the individual statements in that line, trying to preserve some of them and change others, I decided that it would be easier to follow if we simply watch the drawing functionality get rebuilt from scratch.
Okie dokie. Cool.
That we can see everything put together element by element. So here we're starting with a clean draw method. Now before we get into the draw method itself, there's a few things we need to set up. We have our renderer set up in such a way that note positions are externally accessible, and they'll be used internally as well. What we're looking for is the method in our renderer called getStaffPosition. So let's drop in an override to that method. So here as a renderer we have access to getStaffPosition. We'll drop an implementation in place, and we will take out our return call. As a matter of fact, for now we'll simply return vector2.0, and here in a minute we will change this around. We're just setting in a return to satisfy the method itself. Now before we address exactly what happens inside of getStaffPosition, we're going to add another method, this time a method that is private to the horizontal renderer. This is going to be a method that will return an integer, and the method is called getStaffY. And getStaffY is going to take in the current song. So we'll take in a song parameter called song. And getStaffY is going to be responsible for figuring out exactly where on screen the overall staff is positioned.
Okay.
Meaning, do we want it stuck to the exact top of the screen, the bottom, directly in the middle? This is where we'll decide where the staff as a whole is placed. And the reason we're passing song into getStaffY is when we get into multiplayer mode, we're going to need this method to be aware of the fact that a certain staff might be for player 1 and the other staff would be for player 2,
Gotcha.
and they need to be positioned differently on the screen. For now, though, we're just going to return the value 0. So with both of these in place, alright, now that we know what getStaff is going to do, we are going to put a little bit of code into getStaffPosition so that we'll be ready to address some things in the drawing code, because draw is going to be dependent on getStaffPosition when it goes to render things like tracks and notes.
Alright.
So here in getStaffPosition, what we're going to do is assemble some x and y values for the position itself. We'll drop down an integer, we'll call that x, and for the time being this is simply going to be an offset based on the current tick and the center of the screen. If you remember, getStaffPosition is meant to take in any arbitrary note by feeding in the tick and track of that note, and it will kick back a position. So the x is going to be based on the current tick. Now, since we've already defined that we're going to be centering everything on the screen, just like we did in the demo rendering code, we're going to make sure that we offset that tick by the center of the screen. So we'll add the screen center field. Now we need to calculate a position in y, so we'll make another integer called y, and we'll set that to be equal to the total number of tracks. Basically, we'll need to look at or take the track value into account, since it's track that's going to decide how high we are in the vertical sense in y. Now if we take in track by itself, we're going to space the tracks 1 pixel apart. So we need to multiply this by the track height value so that we fully space these. Now we also need to take into account that unlike in the demo rendering code, we're actually going to draw these notes from their origin instead of from their top left corner.
Which is the center in this case.
Exactly. So we need to offset by the origin. So we'll need to add note origin.y. Then we'll also need to offset the entire the entire return value based on where our staff is. We need to make sure that this Y position is relative to the overall staff.
Okay, that's where get staff Y is going to come in right now.
Exactly, because so far we're basing everything off of 0 as the top of the screen.
Mm-hmm.
Now if we add to this a call to get staff Y, of course get staff Y is going to need the current song. We'll just pass song along from the get staff position call. And that way if we move the staff around using get staff Y, then anything contained on that staff, things like tracks and notes, will get moved accordingly. Now you notice at the moment IntelliSense is not happy about some of the types. What's happening here is we've got a floating type coming from the vector2 note origin, and in the end we're storing everything into an integer.
Okay.
So what I'm going to do is take the entire calculation that we've got so far and place the whole thing inside of parentheses, and then cast the result of the entire expression to an integer before storing it into Y. Alright, now that we've got an X and Y value set put together, let's create a vector2 using these elements and return that. So we will return a new vector2 where we will take in X and Y for the vector2's components. So that should take care of our get staff position method. Now we can move down into the draw call. Now to begin with, we're going to set basically, you could say our starting point in Y. We're going to make a value that we can use almost like, I want to call it the origin, but we'll call it span Y since we're only looking in the vertical direction. The idea is that we need to figure out exactly where in Y we should be starting, and we also want to avoid making multiple calls to the get staff Y method. Since we're going to need to draw many things, notes, tracks, and so forth, it'd be a little bit more efficient if we would prevent making any additional calls to get staff Y. So we'll make an integer. We'll call this integer span Y instead of staff Y, since we're actually going to offset it so that it's below the top line of the staff. So we have span Y, and we'll set this to be equal to get staff Y for the current song plus 1. And that'll drop us down inside the staff itself. Alright, now that we have a vertical origin in place, we can turn our attention to individual notes. Now again, some of this code is going to look very familiar because some of it is what was just in the draw method.
Sure, we just wiped that out for clarity.
Exactly, so we're going to start from the ground up and put things back together piece by piece, this time utilizing the actual positioning code that we need for our main renderer.
Okay.
Now the first thing we're going to need to do is to loop through all of the notes that are currently in the song. So we'll recreate the for loop with an index variable as I, and we'll loop through all of the song notes. We'll loop up into the end of notes.count. Now once we're looking at individual note values, we'll give ourselves a local note variable where we'll simply grab the current note, which is in song.notes sub I. Now once again, as we did for optimization, we'll say that if a note is hit, it's not going to be drawn. So we'll say if note.hit, then we will tell the entire loop to continue. So if a note's hit, we won't even calculate where it would go since we're not going to draw it at all. Now if the note was not hit, then we do need to consider where to draw it on the screen. So we're going to make a local vector2. We're going to call this note position. And this will be equal to get staff position, where we'll feed in the tick and the track of the current note.
Of the current song. I'm sorry, no, you're right. The track of the current note.
Exactly.
But we're also going to need to feed in the song.
But we will need to feed the song. It's almost like feeding the song back into the system so that it can tell in multiplayer which song it is and position it in Y appropriately.
Gotcha.
So in the end, we'll need all of the above. So beginning with tick, tick comes from the current note, and we'll look at its tick field. Track also comes from the current note, grabbing its track field, or excuse me. And IntelliSense was being a little bit overly helpful. Make sure we grab track for track. You do have to be a little bit careful here, since both of the parameters are integers, it'd be very easy to accidentally swap tick and track.
Right.
So you want to make sure that everything's lining up before we jump in, because we could get some really odd results if we swap X and Y when drawing notes. Now we do need to pass the current song along, so we'll pass in the song parameter, and then that should take care of our call to get staff position. We'll now have the position of this note stored in note position. Now, in order to see things in motion, we also need to take into account the song's cursor. So this position is all well and good for notes placed statically onto a staff. In order to see them move, we're going to need to offset by our song's cursor. Then, since we want notes to progress off the left of the screen, we actually need to subtract the song's cursor. We can do that by looking at note position dot x, and we can decrement that by the song's cursor. Alright, now that we have the note position solved, there's one more piece of information before we can draw the note itself. We need to know what color to draw the note with. So we'll make a color variable, and then we'll look up the current track inside of the track colors list. So color will be equal to config.trackColors, and then we need to feed in the track of this note, so that'll be note.track, and we'll have that stored and ready for use. Now we're ready to begin drawing. So we'll take our sprite patch, we'll tell it to draw, and we will draw using the note texture. We'll be drawing with a more advanced overload. As a matter of fact, we should be looking at overload number 6. That should give us access to origin so that we can draw these note textures centered on their origin. So that means we need to have a vector 2 for positioning. We already have one of those in the form of note position. The source rectangle is going to remain null since we're not worried about a specific subsection of the texture. We're going to draw the whole texture. We need to specify the color, so that will be the color variable. Now we're required to give a rotation for this overload. We're not going to be rotating the notes, so we'll specify a rotation of 0f. Now we do want to specify an origin, and we have that already stored in the field note origin. We also need to specify a scale. We're not going to be scaling the notes, so we'll leave them at a scale of 1. And also this overload is expecting sprite effects, so we'll give sprite effects of none since we're not going to be flipping the sprite. Finally, we have a layer depth, which we'll specify as 0. So 0f for our layer depth, and that should take care of our entire draw call. Again, the purpose of this more advanced overload was so that we could gain access to the origin-based positioning. Alright, with all of this in place, let's actually drop down and add one more thing before we begin testing. Thinking about it. You know what, I changed my mind.
You want to test first?
Yeah, I'm getting impatient. Let's try and run the game and see if we're getting notes yet.
Well, let's see it.
Oh, look at that.
I see notes. I don't see any sort of line in the middle anymore, and they're not changing color.
Well, that's okay. We don't have the hit marker drawn yet. One thing I will do, since we'll probably need to test this quite a bit, I'm going to turn off the playback just so that we don't have to talk over the sound of the game while we're testing things. So we're going to jump very briefly to screen game, and inside of screen game we're going to look at our note play method, and once again we will comment out the call to soundengine.play. Alright, back to render horizontal. Everything seems to be working well, though we're still missing the hit line, and as you pointed out, we're not changing the notes to red.
Right.
In this implementation of the renderer, we're actually going to leave the missed notes alone.
Okay.
That we were showing red just to demonstrate that our missed field was indeed working.
Gotcha.
Now, here's one thing that we didn't address in the test code, and that is if we have a lot of notes, there's actually a lot of notes that are going to be drawn off screen before they actually slide into view. If we run the game again and you watch the right-hand corner of the screen, you see that a lot of notes pan in, well, not a lot, but in this case, some of the notes pan in from off-screen. If this were a longer song, there would be many more notes off-screen. In order to optimize things, we're going to do a check and make sure that the note position is on screen before we make the actual draw call. And that way we won't waste draw calls on notes that are off-screen. So right here, before we decide what color to use, let's put together an if statement and make sure that the note position is actually on screen. So we'll say if note position.x is less than, well, we could begin with less than 0, because I would say make sure that our position, now if you're looking at that's actually making sure that the position is off screen.
Right.
What we're going to do as a scenario similar to note.hit, we'll come up with an if statement that will actually describe the inverse. This if statement will say whether or not the note is currently off screen, whether to the left or to the right. So the first part of this check is to see, has the note gone off screen?
Okay.
Now, instead of using 0, we're actually going to include the note width in this calculation. Since our notes are positioned around their origin, that means if we drop them all, or if we stop drawing them at 0, you'll actually see them blink out of existence when they get halfway off the left of the screen. So instead of 0, we'll make sure that we go less than negative note width. So that will take care of our notes going off the screen to the left. We also need to make sure that if our notes are off the screen to the right, that we skip those notes as well. So we'll again look at note position.x and see if that's greater than the drawing width of the screen, and then we can offset the note width once again. So if our position happens to be past the right-hand corner of the screen, so we'll look at global state
fixed width.
Fixed drawing width.
Yeah, and then add on the note width.
Exactly, to make sure that we don't have notes popping into existence when they're halfway onto the screen.
Sure.
We'll add note width, and that'll make sure that they pop into existence before they actually slide onto the screen.
So you should get a nice smooth entry and departure.
Exactly. Now, if either of these two statements were true, that means that the note in question is currently off screen, and we're going to skip the call to draw. And we'll skip that call by using a continue statement. That way we'll simply jump past all of this code for drawing and continue on to the next note. So with that, if we try running the game now, we shouldn't see anything different, because the idea is that this is an optimization that only handles things we don't see.
Right.
So if we bring up the notes, nothing looks different. The notes slide on the screen and they slide back off. Now, to make sure that our code is indeed working, I'm going to bring the range in a little bit. So we'll actually offset by 100 pixels on the left, and then offset by negative 100 pixels on the right. And that should bring in a narrower draw range, so we should see the notes pop into existence and then disappear. So there we can see all the notes popped in on the left, and then over here on the right, they disappeared before they got to the left of the screen. So that shows that our optimization is indeed working.
And we're no longer drawing any notes that aren't on the screen.
Exactly. We're just, in this case, with it properly calibrated, we don't ever see it in effect. It just saves us on a number of render calls. Alright, now that we've got our notes drawn very well, positioned correctly, and drawn in a manner that's more efficient, let's take a look at restoring the center hit line. So what we'll do is we'll jump up here right before our notes loop. Matter of fact, let me drop down a comment saying that this loop is for our notes. We'll drop in another comment saying that we also wish to address the hit line. And the hit line is once again going to be a simple thin rectangle that's drawn over the center of the screen. So to put this together, we should be able to do this all as one line. We may break it up into two if the rectangle definition gets a little bit out of hand. But let's start with the call itself. Spritebatch.draw. The texture we'll use is going to be the fill texture. So we'll simply take that 1 pixel texture and stretch it to the size of our hit line. So this will be style.fillTexture. For our rectangle, we'll make a new rectangle where we specify X as the center of the screen. Now if we drop screen center in directly, that means the left of our rectangle is going to be at the center.
Right, so we'll be slightly off from the center.
Right, so that means we need to move it back a little bit to the left. We need to subtract some pixels. So we'll subtract the width of a note. And just to point out here, the width that we will use to draw the hit line
will also be the width of a note.
Exactly, so the hit line matches the width of a note. So we'll subtract note width divided by 2.
Yeah.
That way we'll be centered on the center of the screen. So that should take care of our X component. Now we can address Y, and Y is going to be the top of our span, the top of our staff. So we'll plug span Y in place. We already have that calculated as get staff Y for the current song, offset 1 pixel down.
Right. And since we already decided that we're using the note width for the width of the hit line, we can just plug that into our next field.
Exactly. So now we need to describe
next argument.
The width and height of the rectangle. So exactly, note width will come in and be used for the width.
And we'll just use span height for the last one because that actually fits perfectly into the lines at the top and bottom of the staff.
Exactly. So we'll plug that in, and we'll have a hit line that should match the size of our staff. Now we'll place a closing parenthesis to take care of our rectangle. Then we'll jump over to our color parameter for the draw call, and we'll plug in the value stylecolors.hitLine. Then we can add a closing parenthesis for the draw call, and that should take care of everything. Again, a bit of a long line, but I'm trying to conserve space vertically here in this code, so I'm actually going to be a little bit more lenient on function calls that end up being rather long. That makes things easier to read when you're reading through the code line by line, so you can easily see that, okay, this is the hit line section, and it appears very compact.
Okay.
But again, the only thing interesting inside here is this rectangle definition, which draws a narrow strip with the width of a note over our staff. So with this new hit line, let's jump in place and see what it looks like. Jumping into the game, we can see that it's kind of faint looking. We do have a line, but there's a few problems with it. One, it is rather faint, and two, the colors don't seem to be matching exactly. The hit line appears to be a dirtyish gray color, rather than the bluish gray that our background is.
Yeah.
The reason for this actually ties in to our draw scaling. At the moment, if we look in our game class, let's jump up to our render, I believe it's draw, end draw. Here in end draw, where we're taking our render target and then redrawing that to the real output screen. Now when we go to gather this texture, we're using a sprite batch to draw our render target to the screen. And if you look at the sprite batch begin call, we're using the first overload, an overload with no parameters. That defaults to using a sprite blend mode of alpha. Now in this case, that means we're drawing a texture that has alpha information over a black background, because of course we're clearing the screen to black before we draw. More specifically here, we can see clearing the background to black.
Right.
And what's happening, the reason we're getting this odd transparency issue, is the color for our hit line includes alpha information. And what we're doing is that alpha information is actually adding to or overriding the alpha of this texture as we gather it from the render target. And that's how some of this black color is bleeding through and being seen and kind of darkening that line. So what we need to do is we don't need to be using alpha blending at all when drawing our render target to the screen. We're only going to be drawing one render target.
Right.
So we don't,
and that needs to be considered to be an opaque texture.
Exactly. So in order to do that, we'll take our sprite batch.begin call, and we'll place this as an overload. We'll bring up our parameters, drop down to the second overload where we can specify a sprite blend mode of none. So no blending will occur. Now if we jump in and play the game, we can see that our hit line is much brighter to begin with, since that black color isn't fading through, and the gray color has a bluish tint which matches our development screen.
Cool.
So, alright, what have we got so far? We've got our render horizontal coming along nicely. We've got the ability to position notes. We're using our note positioning to draw all of our notes to the screen, and we have reestablished our hit line. So I think we'll call this video here and continue on in the next video.
Let's do it!